So you may have seen Rubik's Cube mosaics online before, where an artist takes a bunch of Rubik's Cubes and each sticker is a pixel and they create an image with all these cubes.
Whenever they're done building a mosaic, they have to take down the mosaic so they can move on to the next one. And in that process, they have to solve all of the Rubik's Cubes that they use to make the mosaic. So, our goal in this project is to not only make a Rubik's Cube robot, but to make one that you can load in an entire stack of cubes and it'll go through all of them and solve them in sequence without you having to sit there and load them all.
All right, so moving into the operation of the robot, the first subsystem we want to cover is the loading mechanism. So we have this platform right here that's being driven by a stepper motor. It will be raised up, then the servo motor will push a new cube onto the platform, and then it will lower back down.
Once the platform has reached the correct height for the actual solver, the arm in front of the camera gets out of the way, and then the camera is able to take a picture of the top side and the front side. So that gets it 2 out of the 6 sides that it needs to generate a solution. The turning motors will then turn the cube over to visualize the next 2 sides. It'll take a picture and then it'll do that once more before it has a full picture of the entire cube. And then once that's done, the solver can actually move into generating a solution based on that state of that cube.
All right, so once it's generated a solution, it will then send those sequences of moves to the motors. The motors will then execute the moves to solve the cube. Once the cube is solved, a unloading sequence will then commence. The arms will get out of the way, and then the platform will lower, and that will engage the mechanical lever to knock the cube off the platform.
All right, moving ahead into the code, we basically have 3 main pieces of code that control everything. The Python script that's running on my laptop is the main code, so that controls everything. It stores the state of the cube and it calculates a solution and all that. But the ESP32 camera module is running this Arduino script on there, so that's in control of turning the camera on, gathering all of the RGB values, doing all the image processing. And then we have a script running on the Arduino Mega that's in control of all of the servo motors and the stepper motors. If there was a limit switch, that would also be applied to this code here. But in the Python script, what the code actually does is the first thing it does is it tries to initialize the ESP32 and then the Mega. So if there's any problems with serial communication, it'll catch that here, and then you can just restart the code from there. In the main loop of the code, we basically have 5 steps. So we have a calibration step, a loading step, an inspection, and so on. So if the cube has not been calibrated, that is like right when you start the code, if there's no calibration that's happened, we'll basically run this sequence that loads in a cube, takes a bunch of pictures of it, and flips over the cube in between each picture. And then we set the calibrated state to true so that the next time through this loop, this section of code is not called at all. Once you've got it calibrated, you go ahead and load in a new cube. So that'll be the unsolved cube. Once it's loaded in, you inspect the cube. So it'll call the camera to take pictures and then the Arduino to flip over the cube. And then once the cube has been fully inspected, you're basically going to have no more X's left in the state of the cube because it'll be all filled out with different letters, right? Like, so a W would represent white and so on. But once it's got a full cube state, it'll create a cube that's used in the solving algorithm, and then it'll attempt to generate a solution for that. So if there's any problems with generating a solution, it'll throw an error. So that's why we have this try and accept here. If there's any errors, it'll just reset the state of the cube and then go ahead and restart and try and do the inspection sequence again. But if it does generate a correct solution, it'll go ahead and send that solution to the Arduino Mega, which will then just go through the entire thing and execute all of the moves. And then finally, once it's done executing all of the solution, it'll go ahead and launch this unloading sequence. So it'll unload the current cube, and then it'll go all the way back up to the main loop, and then start again and load a new cube.
Let's get into some of the challenges we faced during this project. The first challenge we faced was the lighting. We found that when we were taking photos of the cube for the inspection stage, we were finding different RGB values for the colors based on the lighting in the room. The way we solved this was adding a calibration sequence. This involved turning on the camera lights and then taking a bunch of photos of each color with a solved cube before a real solve commenced. Our second problem was the platform. After we had 3D printed it, the cube would kind of slide off of the slick surface while it was moving up and down just because there wasn't much friction holding it there. So our solution was adding a rubber pad to increase the friction, allowing it to just stay on the platform as it was going up and down. And then our final challenge we faced was the stepper motor. We were finding that it was having a hard time going back to the same place after every solve. So that would then throw off the other positions of the platform in later steps. So when it was loading and unloading, it would be at slightly different heights. So having to readjust that would be is what we're doing now. And then a further solution we could have implemented was adding a limit switch to then, actually give it an accurate reading of where it is every time.